Hello and welcome to our program, Astronomy for Everyone. Our show topic for this month is about the Cassini mission to Saturn, and more specifically, its ultimate demise. With me here in the studio to talk about this topic is our own Kevin Medden, one of our AFE team members. Kevin, welcome to this side of the camera.
Yeah, thanks a lot, Don. It's a privilege to be on this side rather than the opposite side so often as I get stuck on camera.
So we're going to talk about this Cassini mission, and I think you wanted to start with a general history of the mission?
Well, in general, everybody, I think, that has followed the unmanned space program and the manned space program for that matter religiously knows that Pioneer made the first flyby of the gas giants. Saw a little bit, not much, but then along came Voyager. And I can remember, ABC's Nightline with Gene Cernan would come on with Ted Koppel every time there was fresh pictures from either Saturn or Jupiter, and I'm like, I got to see this. And, NASA probably figured out, too, hey, people are watching these. Maybe we need to send something else up. So, of course, as we all recall, Jupiter got Galileo.
Yes.
So they decided to give Cassini Jupiter because as Giovanni Cassini he did a lot of things in his life. Mm-hmm. But pertinent to this program is the Cassini division, which is one of the gaps, I believe, in the ring system of Saturn.
Right, that big wide gap that's visible in just about any telescope.
Yeah, so that's where the name came from, and then we had the controversy before launch.
Okay, and what did that involve?
So all the planning was going well. They knew what cameras they wanted, etc. And they decided, what to use for fuel. Well, once they said nuclear, all the tree huggers and all the environmentalists, they, did the usual panic attack and decided that, hey, we better protest this because if this thing blows up on the pad or if the range safety officer blows it up over the water, we're going to contaminate a pretty big area. So, of course, there was the typical court battles, but
sure,
as we know from history, we survived and we got there.
Yes, we did. And so the nuclear fuel really served Cassini well over its very long lifetime.
Yeah, because when you consider that Cassini lifted off, and I'm doing this off the top of my head, October 15th, 1997.
Yep, 97.
And it had an original, main sequence of 4 years. Then the first 4-year extension was called Equinox, and the second 4-year extension was called Solstice. So, therefore we're talking minus the time you get from Earth to the Saturnian system, mm-hmm. We're talking 12 years of getting a lot of good data.
Sure. And we did. I mean, there's been some beautiful pictures to come back from that. I've used a number of them in the planetarium at the Science Center for some of the shows we've done there.
And if I can see the first slide here, we're going to see a diagram of our friend Cassini. And that explains all the various instrument packages that went along there. And you can see tucked in there is the Huygens Titan probe, which was the little probe that on the 14th of January in 2005, it was able to do a landing on Titan, which gave us good pictures.
Oh, it did. It did. As it descended through the thick atmosphere and the view cleared, it was truly amazing. And
there you can kind of see an artist rendition of Huygens separating from Cassini itself.
That's Saturn on the right and then the Huygens mission exiting down to the lower left there.
Right, and we're making the big assumption that the big chunk there is Titan.
Yes, I think that's a pretty good assumption.
That's...
And so our next image would be?
Our next image will be the liftoff, which, as we have said, took place in October of 1997. And the next image kind of gives you one of these curious things. If we leave it up long enough, you can just get an idea of how many moons were discovered, how many close flybys. I mean, even look at how many nations were participating in this, Don, or down at the bottom, 349 engine burns.
That's a lot of hydrazine propellant.
Or 2.2 billion miles traveled. I mean, try getting that with your average car.
Right, I wonder if they got frequent flyer miles with this.
And then over 3,000 science papers, so you can tell over the course of these 12 years, they've gotten a lot out of this puppy.
Yeah, if somebody wants to know where's the bang for the buck,
that's it right there. I mean, if you're going to run around and say that, nothing was accomplished by spending all that money on Cassini, there's your reality check.
Exactly. So that's, and this is data that we can still be studying for years to come, just like we will with New Horizons to Pluto.
Oh, no doubt. I mean, I wouldn't doubt that you're going to pick up a copy of Astronomy magazine in 2025 or even later, and somebody's going to say recently discovered data from Cassini, went in this direction or something or other.
Exactly.
And next up is the reason, like for Christmas they say the reason for the season. Mm-hmm. In this case, here is the reason for the mission.
There it is. That's
a beautiful sight, and I challenge anybody to find anything, at least in our solar system, that equals the beauty of this planet.
It's truly amazing, and of course you can see that dark space, which is the Cassini division in the rings. And but most folks aren't aware that the fact that the rings aren't solid.
Right. It's it's a lot of rocky core, chunks of various debris and
ice, all just held in separate speedy orbits.
And you have these tiny, what you refer to as shepherding moons that kind of keep things in balance. But I mean, it's a fascinating thing. And here's Saturn with some of her moons, obviously Titan in the foreground, and I mean, good luck trying to identify the rest of them. But again, you're talking about a system that has 62 moons. Of those, 53 have a name. So there are 9 that have a name pending.
Okay.
For various reasons. I don't know why they've chosen not to name them quickly, but as we've seen with Pluto, you can name something instantaneously, but whether or not it survives,
it becomes the official,
right,
quote unquote.
Is a whole other story. And you can see from the shot of Titan, you can see even in that picture, there's a little bit of the cratering, taking place on Titan, and
mm-hmm. It's of course that was a composite picture, of course.
Right, of course. And here's probably one of the things that I find fascinating. Why is this storm shaped that way?
It's a hexagon.
The infamous hexagon storm. And so as we said earlier, Don, the 2 extensions were called equinox and solstice. And when we added the 4 3s or the 3 4s together, we got the magic number 12, and that was the hope, to try to see a little bit of Saturn during every season. And this storm was a perfect thing too to try to get some atmospheric dynamics, try to figure out what makes the storm last, how does it move. I've read anywhere between 200 and 250 mile an hour winds.
Yeah, where does the energy come from to drive a storm that big? Why is the center round and the outer edge a hexagon?
And it's really interesting. You delve deeper into why we went up there, and weather is a big issue because even on Jupiter they want to study the weather more. But the interesting thing is that they're like, wait a minute, not even sure we know some things like how long is a day on Saturn and different things. They're still fine tuning that with the data that they're discovering, and to me that's fascinating that everything's a work in progress.
Exactly, and like we said that before, to be mining data from this for years to come is really going to be exceptional. And I think we really have a lot to look forward to as we move ahead in the years. Now, we're going to take a quick break from this discussion of the Cassini mission. If you have a question, please send us an email. We always ask you to do that. We do like to hear from you, and you can see the address down there at the bottom of your screen. And coming up next with Stephen, of course, as always, is Term of the Month. And right after that, we'll be back with more of our discussion of the Cassini mission to Saturn.
The Term of the Month for February 2017 is Maneuvering Fuel. Cassini ends its mission by diving into Saturn so that it does not contaminate any moons with any stray bacteria that might be stowing away on the spacecraft. Cassini runs out of maneuvering fuel. It has 2 types. It has a monopropellant called hydrazine, And this is used for small maneuvers and reaction wheel momentum management. And it has a bipropellant, which is monomethylhydrazine and nitrogen tetroxide. And that's for big maneuvers, such as the final plunge into Saturn. The mission started with 3 metric tons, roughly, of propellant, and in 2010 it had only a couple hundred kilograms total. Now it's running on vapors, and that is the term of the month, maneuvering fuel.
Thanks, Stephen. And welcome back to our conversation about the Cassini mission to Saturn. Now, Kevin, Cassini not only studied Saturn, of course, it also took a lot of long looks at the various moons of
Right.
Saturn, and we're going to talk about that next, right?
Right, and it was very difficult trying to assimilate as to which moons to eliminate. So the first moon I picked to kind of show off was the one named Hyperion. And Hyperion, as you can see, is not totally spherical.
No, it's not.
So this was one of the first moons that they gave the name irregular moon to kind of compensate for the fact that it's not the typical sphere that we see when we walk outside and see our moon.
And its surface texture is so different. It almost looks like a sponge.
Right, exactly. And surprisingly, there was a lot of pictures of this, but I liked that one the best because it did give you the 3D effect of that sponge-like look you were talking about.
It does. Not only can you see impact craters, but it almost looks like it outgasses like a comet
Correct.
to create some of that texturing, because it seems to have, some of them have a certain directionality. It seems like there's water vapor or something streaming out like you would see.
So
on a
I'm
comet.
sure they're going to discover more about this moon even once Cassini does meet its demise. And the second moon that I picked is Enceladus. And this is a shot of the North Pole craters. And I chose this one because it was the one that kind of surprised them. I don't think they were expecting as much out of this moon as they did. And as the second shot will show, what do you see coming out of that?
Geysers.
And that was kind of an interesting thing, because what is the mantra of NASA? Follow the water.
Exactly.
So this is one of the instances where further study is probably going to be in NASA's plans, because obviously these jets of water have given them an indication that it's worth going back to see if there is, an ocean down below, or just, some kind of surface water.
Much like Europa.
Correct.
At Jupiter. And then you wonder what's going on inside Enceladus to drive this water out. What's the mechanism that does that? And it's just a fantastic view.
And the final moon that we're going to discuss is obviously the king of the Saturnian system, and that's Titan. And that is your basic surface shot where you can kind of get an idea of, and I'm sure the experts at NASA could tell you what each color means. It probably represents a particular type of topography, or
if it's in the clouds, the elements.
Right,
the clouds are primarily nitrogen.
And the next shot is kind of a complicated shot, but you see the word Montes, which obviously means mountain.
Right.
And that's a kind of a composite of all the big mountains that are found on the moon Titan. And if I'm not mistaken, this shot was taken from the Huygens probe going down in toward the moon itself. And our next shot is the lakes.
I
know
like
this
shot.
this isn't Michigan, and this isn't the Great Lakes, and that's not water. Those lakes are made out of methane.
Yep, liquid hydrocarbons. Yeah.
So, and there's another shot of the northern region of Titan. This is called the North Lake shot, and you can see some of the data points are missing.
They appear white
with the white blanks like that, but still an interesting shot. And our next shot takes us even closer to the same region, so this is still the northern lakes.
And you can look and see rivers.
Right.
It just looks like a river delta on Earth, only instead of liquid water flowing.
You can see them all meandering and all the branches. it makes you wonder how much of that system is very, very similar to ours.
They have said that Titan probably resembles a very early Earth when our atmosphere had a lot less oxygen and more nitrogen and other elements. Of course, the temperatures obviously are much colder.
Yeah, I wouldn't think I would be bringing my swimsuit to Titan anytime soon.
Nope. Here on Earth, methane is a gas, of course.
And the final shot we have of the moon Titan are what NASA has labeled as mystery clouds. In
the lower one, it almost looks like they have a fluorescence or luminescence to them.
Right, and that was one of the reasons why we were glad we found this particular shot, because if I went strictly with that top shot, you don't get a feel for anything because there's no color in it.
No, it's just a typical black and white shot. But
okay, now this is a shot also of Titan, but this is Titan performing what is known as a transit. And you can help me with this, but that's one heavenly body going across another?
Going in front of the other, yep. And in this case, you can even see it's transiting the rings.
Right.
The shot is the
so
plane of the
it
rings.
almost looks like the rings are going right through Titan.
Yeah.
And that's similar to what we've just witnessed with the transit of like Venus and Mercury based on the sun. And the next shot that we're going to do is kind of the complicated, what NASA calls the grand finale. All the orbits that they have to do at the particular time to get Cassini in position for its last hurrah. And you can see on the bottom where it says Titan's orbit.
Right.
That's because, again, Titan, a very large moon, they're going to be able to get a little bit of gravity assist out of Titan to set up these final orbits as Cassini meets its demise on Saturn. Now, if you recall, Don, when we talked about the controversy before launch,
yes,
this is where the puzzle meets together. The reason why we are having the final demise on the planet versus the moons is we're 99.9% there's no Centurion people crawling around on Saturn, but we're not sure that the moons don't harbor life. Therefore, if you're going to send Cassini off, send it into the planet versus the moons.
Not contaminate them.
Correct.
You don't. Nuclear fuel.
Even if you're wrong and there is no life on those moons, why take the risk?
Exactly. Plus, they can use Titan, as you were mentioning a moment ago, to help with the adjustments of the orbits, since Cassini is so low on its hydrogen fuel for making adjustments, and so that helps them out there, not running out of gas partway through, and then they go, oh my God, now what? Yeah.
So now our viewers at home can mark on their calendars 9/15/2017. That'll be the final date when Cassini finally meets its demise. And Don, I couldn't think of a better way to wrap up a discussion on Cassini as to show where Cassini originally came from. And there's the pale blue dot, 900, some odd million miles away.
Yep.
That's us, people. That's what we look like if we were a person in the Saturnian system. And it kind of gives you an idea of, exactly how fragile our planet is and how insignificant we are when you pull back that far away.
Yeah, kind of puts things more in perspective.
And just briefly, Don, if anybody wants more information about this, they can pick up the January 2017 copy of Astronomy Magazine, and it's a very good article, and you can get more details as to the demise of Cassini.
All right, well, Kevin, thank you very much. I appreciate you bringing this information to us so we can disseminate it to our audience. And as always, for more information, visit our club website. The website you can see right down there at the bottom of your screen. We like to have you check that out as well. And once again, Kevin, thank you very much for imparting the information. Coming up next is What's Up in the Night Sky with Stephen Whitty. So don't go away. Listen to what Stephen has to say and enjoy.
What's up in the night sky for February 2017? The days are getting longer. So at the beginning of the month, the sun rises at 7:46 a.m. and sets at 5:48 p.m., at least in Michigan. And on the 28th, at the end of the month, the sun rises at 7:09 p.m., so a bit earlier, and sets at 6:22, quite a bit later. So with that, we go to the moons. The first quarter is on the 3rd of February. The full moon is on the 10th. The third quarter is on the 18th. And the new moon, which is when you get to see all of the faint fuzzies out in the sky, that's on the 26th of February. Now, in the morning during February, we have this sort of lineup. Mercury actually gets lower and lower, so Mercury is the best at the beginning of the month. We just had the greatest western elongation on January 19th. So by the end of the month, the Mercury is gone. But here at 7:30 in the morning on the 1st, we have Mercury rising really like 7:15. It's actually just a little bit before this. Pluto is higher in the sky, but it's so faint that this is not a very good time to look at Pluto. Saturn rises at 5 a.m. It's actually good from maybe 6 to 7 a.m. And Jupiter rises at 11:37 p.m. It is good as early as 7 a.m., so most of the morning from midnight. In the evening sky, we have Neptune, which sets at 7:15. This is probably your last chance to see Neptune. Oh, and this is at 7 p.m. We're looking at 7 p.m. mid-month, so I'm talking about the times in the middle of the month. It's an hour earlier or later for most planets, depending on the time of the month. Venus sets at 9:15 p.m., Mars sets at 10 p.m., and Uranus sets at 10:30 p.m. Now, if we look at the solar system sort of from the top, everything's rotating counterclockwise in this view. If you draw a line from, in the inset, if you draw a line from the yellow sun in the middle, which I didn't label, out to Earth, then anything sort of to the left and down, and you can project that out, is a morning object, and everything to the right and down is an evening object. And with that, we're going to go to a video that NASA Goddard put together about the moon, and it shows a number of interesting things about the moon all year in 2017. So in the lower right-hand corner, you have the time, which gives you the date. And we're starting in January. Now we're publishing this starting in February, so this is in the past. And you can see on the moon that different objects are labeled. Different craters and other features on the moon are labeled as the phases change. This video is now on YouTube because it's part of this show, and this show is on YouTube. And if you do have it downloaded, then you can pause it anywhere, and you can actually look at these labels, and you can spot which craters and things that they are referring to. So on the going further on the right, on the lower right, there's the current phase of the moon in a percentage thing, and also how old the moon is. Starting from new moon and on. The diameter of the moon, the apparent diameter of the moon, changes as you kind of see this thing. It's kind of shrinking here, and then it grows, and also it's the whole moon sort of wobbles left and right in what's called a libration. The moon actually does sort of rotate as you see the view, so you can actually see a little bit more than half of the moon. You can see the moon rotate just a little bit beyond one side, and then just a little bit beyond on the other side as well. So On the upper left, you can kind of see the Earth is rotating and illuminated by the sun, and then the moon is going around. So you can kind of see what that looks like, almost like the Ori that we show in What's Up, the top-down view. And then in the lower left, we have, you can kind of see the librations, well, you can see the tilt of the moon going back and forth with the axes labeled, but you can also see the libration. It's sort of the rotation. I think it's easiest to see that sort of that ellipse. Here we're leaning to the right, and then we leaned back to the left again. So here we are already at July. We're past halfway through the year, and we are still seeing all of those same sort of objects. So you can pick out like the bright crater 2/3 the way up, Tycho, or Copernicus, I'm sorry, and you get to see the label. Especially if you're looking for it, you can actually see the label spot on the object again. So here we are. We're in September. So it's already fall on the Earth. So you'll be able to see. At least in the northern hemisphere, you'll be able to see earlier because it gets dark sooner, and you get to, and it's still not freezing cold. 6 months before that was probably greater. It was the great season for the southern hemisphere if you're far enough south for it to matter. There is so much more land area on Earth north of the equator than south of the equator. So right around first quarter, there are some really quite interesting, when this line is almost vertical, there are a whole bunch of interesting objects on the moon to check out. And I encourage everybody to look for these little things. So my other favorite feature is the dog on the moon, which is on the right side. And the dog is facing left and so forth. So here we are coming up to almost the end of the moon, and just want to say that Astronomy for Everyone is free, but we may tax your brain.